So today we got a medium problem, valid parenthesis string, given string containing only 3 types of characters, left, right, and asterisk. Return true if it is valid. It is valid if, okay, right has to have, left has to have right, right has to have left. Left must go before the corresponding right parent single. Oh shit. Okay. Wait. Oh, or as an empty string. Okay. So I think basically we keep dp free of each. We can't go under 0, of course, and then whew. Okay, so here is what the dp we are going to be doing. We'll have dp free where dpi 0 is balance of first I chars if each char is empty string, which of or none if the if char is not this dpi1/2 first I chars if each char is left bracket right. So n s, and then most of the time and ideally we want, like at the end we want to check all 3 of them and check their balances, and if they are not known, right, so we're gonna have like dp is known for and then we're gonna have like I should just do n, and then if s0 is this, then dp00 is 0. It's this, then dp01 is 1, right? So that's just the base case. Else dp02 is -1, but that should already return false because we cannot do that, right? No, actually, and dp01 is 1 because it can be anything. It cannot be the closed one because then we should return. Okay, and now we go for the chars. Okay, and now basically we do the almost same logic. So what we want to do, well, the length of the string is small, but maybe since it's medium, they probably want to allow a bad solution, maybe. Not sure. If SI is equal to opening bracket, then here is what we are gonna do. No, that's not gonna work. Okay, new definition. We are processed this many characters, this is the balance, and that's about it, I think. And now maybe it will work, I'm not sure. So what we wanna do, if I len s return true, so if we got return balance is 0, and then what we want to do, well, ans is false. So what we want to do is return solve I plus 1 these are the choices, so false if si is equal to this, then we want to do and solve I plus 1 b plus 1, return true if si is this, and solve I plus 1 balance decreases, return false if at any point we have balance under 0, return false because that's not possible, true, otherwise return solve I plus 1 b plus 1 or solve I plus 1 b minus 1, finally return 0 0, and then we just slap LRU cache on top of this. So basically I'm brute forcing. But smarter, maybe? I don't know. Oh, like this. Great, this should pass. No, it doesn't. Returns true. Interesting. I think the mistake is that if the character is neither of those, then the last thing runs, but okay, fair enough, that works. I could do that with a DP, but I'm not sure. I mean, I could do it like, I'm not sure if I want to be honest, but okay. I don't need n, I guess. Or do I? I don't know. Yeah, Let's just do this. That's enough, I think. Overview, top down DP. I guess that's NN. Bottom up and tabulation. Okay. Using two stacks. Oh. 2 pointers. What the hell? Oh my, what the hell? Okay. Okay. I mean, I get their point. The point is that depending on the state of this, you wanna maybe preferably close. I'm not sure. So you go, if you meet this, you have open count, otherwise you have close count. Fair enough, I guess. Wildcard options. Where in the string we are and what is the current balance of brackets. +1 for opening and -1 for closing bracket. If at any point the balance goes under 0, we abort that route. If we reach the end of the input string and end of the input string, and the balance is 0, it's possible to build. Okay. The balance increases if SI and decreases when SI is a wild card if Si is a wildcard, then the balance can stay the same or increase or decrease, so we check all options if at least one of them returns true. O of n squared, since there are O of n squared states, since there are O of n possible locations in the input string, and O of n possible balance states. And we do O1 work for each state. O n squared, since there are O n squared states, as mentioned in the last paragraph. Okay, I don't have the brain power today for this, so I get suboptimal solution. Goodbye.